Okay, in this video we're going to continue where we left off and start working with conditional statements. These are statements in computer science that allow you to execute computer code or statements conditionally based on a particular value. Okay, so let's open up our notes that we've been taking here. Got a new terminal, change directories to my desktop, and I'm going to run Atom. Again, you can just click on the icon of your operating system and go to File, Add Project folder, and then add your desktop if you'd rather do it that way. Okay, so here's our notes. This is where we left off. We've been talking about operators and expressions and different types of data, literal data, the basic data types, which we have string, integer, float, and Boolean in Python. Various types of expressions that evaluate to single values and Boolean expressions that evaluate to a single value of either true or false. Now, Boolean expressions are especially important when we start talking about conditional logic. Okay, so down here at the bottom I've started conditional statements. Okay, this makes use of the keywords if, elif, and else. Basically, if is saying if something is true, execute a certain block of code. Alright, so here is an example. This is what it might look like in your file, in your coding file. We would say if some Boolean expression is true, if this Boolean expression evaluates to true, and then you have a colon. And then this is where indentation becomes very important. In Python, indentation designates code blocks. So any code that is indented under this conditional statement, that code is considered a code block, and it will execute if the Boolean expression here is true. Okay, so if this is true, when Python starts reading the lines of code, then it'll execute these lines of code. If this is false, it skips over these lines of code and continues on where it left off. So the indentation is very important. That tells us what code is part of this if block. Alright, so let's do a couple basic examples. We'll make an empty document. We'll rename this conditional.py. Alright, and it's very simple. If true. So this right here, what's highlighted, not the colon, this is the simplest form of an expression we can have. It evaluates to one single value. In fact, it is the single value that it evaluates to. Okay, so if this expression evaluates to true, which it always will because we've got a literal true value there, then that means we're going to execute the indented lines of code, so the code block. So this code block we're going to print. Python will always print this. Okay. Then, once it's finished executing that code block, it goes back to the main indentation level and continues executing code just like it normally would. Alright, now it encounters another conditional statement. If false. Okay, this is another very simple Boolean expression. It's just the value that it evaluates to. So this one always evaluates to false, which means that this code will never be executed. Python will never execute this. All right. So let's open up our terminal. And let's run this. We use Python 3 and then conditional. Python will always print this. So notice, Python goes line by line. If there's nothing on that line, it goes to the next line. It sees an if statement. Okay? This is a conditional statement. If is a keyword. When it sees if, it's expecting some Boolean expression next. Okay, I can have a very complicated Boolean expression. I could have something like that. I can run this. Alright. True and true is true. If we go back and look at our notes really quick, to the Boolean values and, okay, true and false yields false. Everything yields false except true and true. So that yields true. So true and true is essentially just true. Alright, and then we have the Boolean expression true or false. We look back at our notes, the or, true or false. That yields true. So this whole thing essentially yields true. Alright, so you can have complicated Boolean expressions here. And usually you won't be using Boolean literals here. What's more likely to happen is you will have a value, say S for example, and we want to get some input. Okay, so let's do that underneath here. Okay, this is one of the reasons Atom is very useful as an editor. I can just hit Control up and it moves this line of text up, and Control down moves it down, so it's easy to move code around. Alright, so we're going to leave our two if statements alone. I'm going to get some input from the user, and I'll say enter something, and I'll say if, and then I'll convert this. Anything we get from the input function is string data, remember. Okay, so let's convert it to a Boolean value. So if we have a Boolean value for our string, okay, what does that mean? If we look back in our notes and we convert string data to bool, let's see, Boolean data, it yields true for everything except the empty string. Okay, so as long as the user types something in here, this is always going to be true, as long as the user types something. But if they just press enter without typing something, then this will be false. You typed S. Okay, so this is a print function, and I'm passing in two arguments. I'm passing in this string literal, and notice there's not a space here, and then a comma and a second argument. The print function automatically puts a space between each one of the arguments you give it. Okay, so there is going to be a space between between this string literal you typed and then this value you get back. Okay, now we're going to have a continuation onto this if statement, the conditional if. So if that's true, if the Boolean value of S, which means if S is not the empty string, if it's not the empty string, then we're going to print out what they typed. Else, if it is the empty string, and notice we have this colon again. The colon always means you're going to have a code block. You're going to have indented code. Okay, so else, we make sure we indent, and we say print, you did not enter data. Okay, so this is more common to what you might use an if statement for. You have some variable and you don't know what the value is. If it's a certain value, do one thing. Otherwise, do something else. It's conditional. The code that runs is based on the condition, whether or not this condition is true. Okay, and this is part of why Boolean logic becomes so important in computer science. All right, so let's save this file and we'll run it. Python will always print this, right? So our two if statements are still holding, and now we have our input. Let's print hi. It tells me that I typed, and then the program exits. We're back to the command line. Okay. So what if I run it again, and this time I'm not going to type anything? I'll just press enter. It says you did not enter any data, right? You did not enter data. Okay, so this is conditional. Based on the value of this Boolean expression, if that's true, we execute this code block, and there can be multiple lines. Okay. Notice everything is considered part of the code block that is at the same indentation level, and that is one indentation level farther than the original if statement. Okay, so we have the if keyword, a space, Boolean expression, as complex as you would like it to get, and then after the Boolean expression, which is this, then you have to add the colon. The colon designates a code block. That means there's going to be indented code coming up. Right? Now we don't have to use an else. See up here we didn't use an else. So if this is true, it prints this. Otherwise, it doesn't matter. It doesn't do anything special otherwise. It just keeps going. It comes back to this indentation level and comes down. All right, then it sees another if. If that's true, it does this. But this is never true. This is a literal false value. So this conditional statement will always fail. This code will never run. All right, and then it comes back to the main indentation level and runs one line at a time. Then it sees another conditional. If this evaluates to true, it executes this code block, each line one at a time. Okay, if this conditional is false, then it moves to the else block. Prints this code block one line at a time. Okay, so let's try it again. You typed hi, another line, and 256. And then if I don't type anything, you did not enter any data, and 16 squared is 256. Okay, 2 to the 8th is equal to 16 squared. Okay, so that's basic conditional logic for you. We used if and else. Those are the most common. There's also an else if. Okay, and I'll show you some examples here with that. Okay, so we'll go ahead and we'll put this code in our notes. And we'll put a little comment up here that this is conditional.py. The comments will be ignored. Okay, so then you can just copy and paste this code into a file and run it with Python. So everything in between these big hash lines here. Okay, so let's try another program. We're going to test if something is a square. Okay, so is square.py. Okay, in this case I've named my file. It's 2 words. This is called camel casing. It starts out lowercase and each word afterwards is capitalized. So the name of this file is square, and I'm using camel casing. So I create that file, go into this file and add them, is square.py, and I'm going to start out and we're going to do some basic Boolean logic here. Is rectangular. Okay, so let's say I have a shape and it's possibly rectangular. Has 4 equal sides. Okay, so both of these are identifiers. These are assignment statements. You have an identifier, which is a variable name, an equal sign, and then a value you're assigning to that. And this is an expression. An expression evaluates down to one single value. Whatever it evaluates to is what gets stored in the variable. Okay, so we start out with 2 variables, and now we can do a conditional statement. If the thing that we have is rectangular, and, okay, now this is a special keyword. You see in Atom it highlights, that is the Boolean operator and. If we go back to our notes and scroll up, we have Boolean operators and, okay, false and false, right? We have a variable name and another variable name. Okay, so here you get to see why it's called the AND operator. So if this thing is rectangular and it has 4 equal sides, print you have a square. Okay. So you see, this is basically the same way we use human English language, right? We have if this thing is rectangular, so if that is true, and also this thing has 4 sides of equal length, then that thing is a square. Okay, so if both of these are true, that's how AND evaluates. Both items have to be true, and then the entire thing is true. If this is true, then we execute this code. So if something is rectangular and it has 4 equal sides, it is a square. Okay, so let's save this and run it. So Python 3, and the name of this file is square in camel case. So it says you have a square. Alright, so let's try something else. Let's make a new variable that's called isSquare. And we're going to say isSquare is equal to is rectangular and has 4 equal sides. Okay, so this is an assignment statement. We have a variable name or an identifier. We have an equal sign. It means we're setting a value to this variable name. And then here is a Boolean expression. Is rectangular is true, has 4 equal sides is true, and there's an AND statement. True and true is true, so is square should be equal to true. Right? Now if we copy and paste, we won't copy and paste, we'll just do if is square. So if that's true, which it should be, then we're going to print you have a square. Okay, so you see, we're doing the same thing, but we used a different Boolean expression. Sort of. Okay? Before, on the if statement, we had the Boolean expression directly in the if statement. Here, we made the Boolean expression, we stored that value in a variable, and then did the if with that variable value. Okay, so it's essentially the same thing, you can just write it a little bit differently. So you can have a Boolean expression here, or a variable holding a Boolean value. Okay, this is also considered a Boolean expression. It's just a simple one. Okay, so we'll save that. And we run Python 3 is square.py. You have a square, you have a square. Alright, now let's change it up a little bit. Let's make it a rectangle. So has 4 equal sides is going to be false now. So we're changing the value of has 4 equal sides. Okay, so now let's just copy and paste this again and see what we get. Up here is square is true because is rectangular is true and it has 4 equal sides is true. So this true and this true is equal to true. So is square is true, which is why this one prints. Now we've changed one of those values. However, is square is still true because this evaluates down to a single value. It doesn't run this expression every single time. It runs this expression once at this particular point in time in the code. This is true and this is true, so this value is holding true, and it doesn't matter if you change any of these values after that. Okay, so is square is still going to be true even though we changed this value. Okay, so let's save that. See, we still have a square. That still means is square is true. Now if we want to check and see if we have a square again, we can run this code again. We can copy that code. I can say is square, and I can say is that equal to, or I'm going to set that equal to is rectangular and has 4 equal sides. Okay, so now I'm executing this code again. Now I'm running this expression again and storing the result in is square. This time has 4 equal sides is false, so this part of it is false. Is rectangular is still true, so we have a true and a false. Okay, so we look back in our notes, true and false yields a false. Okay, so that means is square should be false. And if we run this again, we should not see this line because is square should be false. Okay, so we should still only see 3 lines of is you have a square. And sure enough, that's what we see. And we can double check that by saying else print is square, and we could print out the value of this variable just to make sure. Okay, so this is a label. It's a string literal. I'm printing this out, and it's going to have a nice little label with a colon. That's just optional. I could, I could do an arrow, or I could do whatever I want, or I could say it equals. But this is just a label, and then it's going to print out the value held in this variable. Okay. So we'll save that and see is square is false, and so we go to the else statement. So if this is true, we run this code. If it's false, we move on to the else statement and run this code. Right, and that's what we see. And then it says is square, that's our label. Right, and there's no space here, but the print command, the print function, puts a space between every argument you supply it. Okay, so is square is false, so it adds a space and then prints out false. Okay, so that's another one with basic Boolean logic. We can add that to our notes. And I recommend you go through these notes and try these programs out on your own. Try to write them on your own, and if you can't, then copy and paste and do that as well. Really, you should try to do all of this on your own. It'll help you tremendously. Okay, so this one is called is square.py. All right. So there's that one. Now let's make another one. Let's see if we can do something more meaningful, something with numbers. Okay, so let's multiply a number by 5. So this is going to be called multiply by 5.py. Okay, so first we want to get some user data from using the input command, and I want to tell them specifically what I want them to enter. Actually, let me do this in the Atom editor so we get colorization. Let's add a new file, and we'll call this multiply by 5. Okay, so this is a comment. It's kind of grayed out. It's because Python ignores it. Here's an identifier, which is a variable. This is an assignment statement. We're using the input function, and we're going to say enter a whole number. And if you remember from your math classes, that's 0, 1, 2, and then anything on up. Okay, so we want them to enter a whole number. Alright, so let's start, and we'll try to convert that string data, because whenever you use the input function, you get string data back. We can test that real quick. We'll print out the type of this data. So we run the program, Python 3, this is multiply by 5, enter a whole number, 1, and that is string data. Okay, we want to convert that string data into a number. So how do we convert? We need to use the integer function, and we want to put in that user data as the argument. Okay, so this should be the string data that the user typed. So in here I typed a 1. So what was stored in there was a string value of 1. So now number should be integer data and the value of 1, assuming that's what I type in again. Okay, so let's test that. Print, and I want to print out the type of data that I have, and I want to print out the type of my variable num. I run it, type in the number 1, press enter. So the first one is a string, and now this one is an integer. Okay, so if I want to multiply by 5, then I need to print out number and then times 5. This is an expression. This is all one argument sent to the print function. Okay, I could add a label like that. This is one argument. It's one string, literal. The next argument is an expression. This will get evaluated. If I type in the number 1, that would be 1 times 5, and that's going to be 5. Type in 1, your number multiplied by 5 is 5. Okay, notice there's 2 spaces here. That's because I added a space here, and then Python adds an extra space between arguments. So if I only want 1 space, I need to get rid of that one. Alright, let's try some other numbers. 25. That's 125. Okay. So now you can start to do a little bit more interesting types of things. All right. Let's do a test, because right now, if I run this and I don't put in a whole number data, let's say I put in Apple, we get an error. Okay. Let's protect against that, and we can check and see. It's trying to convert Apple here. If we look at the code, it says in file multiply by 5 in line 7. Okay, that's line 7 right here. It's trying to convert the string apple to a number, and that doesn't make any sense. So it says, nope, not going to do it. So let's protect against that. We can say if our user data, there's a built-in function attached to strings. So you can say dot is digits. And if all of the digits in the string, or all of the characters in the string, are digits, meaning they're 0 through 9, then this will be true. Okay, which is why we can use whole numbers. It won't work for negative numbers. If it sees the minus sign, that's not a digit. Okay, so that's why we say enter whole numbers up here. So if it's a digit, then we'll go ahead and do this conversion. We'll print out this information. Okay. Now, if it's not a digit, we jump down to this else statement. And we can say, you entered invalid data. And I can say, I can print out the data they typed. So user data, like that. So let's run it again. Enter a whole number. I say apple. User data dot is, oh, I think it's is digit. There we go. So the function name is digit. Okay, and built-in Python functions, they just, even if they're multiple words, they keep them all lowercase and smash them together. It's actually kind of hard to read, but that's kind of the convention for built-in stuff in Python. So you see there's 2 words here, and they just mash them together with no space, no underscore, no camel casing, anything like that. Okay, but usually when you make variables, you're supposed to put like an underscore. You don't have to, you can make them however you want, but that's just kind of a guideline. Okay, so now we've created something a little bit more interesting. Depending on what somebody types in, we can output different data. So you could make a game where it's like, guess what word I'm thinking of, and then they would try to type it in. And if they got it right, then you would tell them they got it right. Right? You could have a secret code or something like that. Right? So you're starting to see that you can do more interesting things with computer science, but you use conditional logic constantly.